Maintain and repair automation and control systems of main propulsion and auxiliary machinery. Pressure sensors. Types of pressure sensors. 7 types of pressure sensors. Pressure sensors are designed and categorized according to the configuration they use to sense pressure changes. The different types of pressure sensors are listed below. Aneroid barometer pressure sensors. Aneroid barometer pressure sensors are purely mechanical devices to measure pressure. These types of pressure sensors are composed of a hollow, airtight metal casing with a flexible surface, resembling a capsule. Atmospheric changes cause the capsule to compress and expand, causing it to change shape in response to the surrounding pressure. The level of deformation can be measured and coupled to a dial that translates the pressurized deformation to a corresponding pressure reading. Manometer pressure sensors. Manometer pressure sensors are glass tube, fluid-type pressure sensors that follow a simple design structure. However, they have an accuracy greater than aneroid barometer pressure sensors, which is impressive as they were one of the earliest devices invented to measure pressure. The movement of the liquid-filled tube compares the pressure difference between the two surfaces. The most common manometer sensor is U-shaped. Pressure is applied to one side of the glass tube, displacing the liquid inside, which causes a drop in the fluid level at one end of the tube and a rise at the other. The difference in height between the two ends of the tube indicates the pressure level, and a measurement is taken. Bourdon tube pressure sensors. Bourdon tube pressure sensors function on the same principle as aneroid barometers, yet, they have a helical or C-shaped sensing element instead of a hollow, airtight metal capsule. They are innovative mechanical measuring devices that use physical movements. One end of the tube is closed, while the other end is exposed to the surroundings being measured. As more pressure is applied to the sensor, the coil, elliptical cross-section, of the tube begins to straighten. The Bourdon tube continues to straighten until the fluid pressure matches the tube's elastic resistance. It is the physical motion of the coil that moves the pointer along a graduated dial to display the pressure readings. Vacuum pressure sensors. The above pressure sensors generally work by measuring an applied force to a mechanical apparatus. However, when mechanical methods become complex and the pressure drops below atmospheric levels, pressure sensors that observe and measure the effects on the material are used. This is where vacuum pressure sensors come in. Sealed pressure sensors. Sealed pressure sensors are commonly used to measure atmospheric pressure at sea level on submersible vehicles to establish depth by measuring and comparing ambient pressure alongside available atmospheric pressure in the sealed device. The chamber maintains the same air pressure since it was sealed, which becomes the permanent internal reference pressure of the pressure sensor. Piezoelectric pressure sensors. Piezoelectric sensors work by employing an electric charge as a response to physical changes to the material. The charge created from physical changes is directly proportional to the applied force. The piezoelectric pressure sensor measures and calibrates changes in the electrical charge, displaying a corresponding pressure measurement for the user to view. Strain gauge pressure sensors. As the name suggests, strain gauge pressure sensors use the proportional expansion or contraction in the spring's dimensions to measure pressure. When a force is applied, the spring element inside the strain gauge pressure sensor deforms. When pressure changes occur, the resistance fluctuates and voltage readings are recorded as electrical signals. These can then be converted to an equivalent pressure reading and displayed by the strain gauge sensor.